Good morning, everyone. Good morning, Shubham. So, did you spend good time in the Saturday lab? Has everyone gone through? Has everyone revised what we said regarding threads and the synchronizations and the problem without the threads? Did anyone attempt the assignment of applying thread safety to collection? It was a very easy one. Have you tried applying thread safety? There was one assignment given. Is it working or not working? Trying still. Okay. So we'll continue that discussion in your lab session in case anyone requires help. So since we are going to start today your advanced Java, some of the topics, I'm going to take some of the pending topics. There are more also, but that I'll take later. But these are the 3 topics I plan to take right away. So of course, after the revision. So let us start with our daily revision. Anyone wants to tell me, when people ask you what is synchronization, what is the meaning of synchronization? Simple question, simple answer. It is nothing but applying thread safety. I hope you have gone through the readmes also, applying thread safety, or you can say applying locks. Why a synchronization is required? Or let me say this, if you don't apply synchronization, what will happen? What it will result into? What it may result into? Race condition. So why synchronization? To avoid the race condition, which may spoil, which may garble the output, which may give you the corrupted output or unpredictable results, or in some cases exceptions, concurrent modification exception, type exception. To avoid the race condition, that is to guard a critical section. So what is critical section? The code, the part of the code which is prone to race condition or which may produce unpredictable results the moment the sequence in which threads are executed changes is the critical section. So to plug that, to avoid that, we apply synchronization. So this is a more elaborate statement when it is required. In a single threaded system it is required, or multi-threaded system? In a multi-threaded system. So in the, is it required if all the threads, different threads are working on their own resources, or is it required when they're working on the shared resources? Shared or different? Answer is shared. In a multi-threaded system, when multiple threads are accessing the same shared resource. Can you give me a couple of examples of shared resource? Which is the shared resource you had used in the assignment? What was acting as a, okay, that was our classroom discussion, right? And what is it you were using in your assignment? The assignment I'm saying. What was being shared between the two? Random number was not shared. Wrong answer. Random number was created in every thread. Answer is array list. I think it was, I had given you array list based, right? So any collection, array list, linked list, or hashtag. I think I'd set up array list example. Or it could be a joint account, as you said rightly. Or it could be a file, data file. It can be any device such as socket. It can be in the reservation system, the seats, anything. Wherever there are multiple customers represented by multiple thread are trying to compete to access the same resource at the same time, you have to think about concurrency. Next question. Suppose you develop a book my show type of example, and if all customers are only going to view what are the free seats, is it required or is it not required? If all the threads are just reading from the resource, is it required? 100% not. So when it is required, in a multi-threaded system, this is shared resource, and when some threads are reading and others are updating the resource, then definitely you require thread safety. So if you are working with an immutable object whose state cannot be modified, so are immutable objects inherently thread safe or inherently thread unsafe? Now I think everyone should start understanding. Guys, I don't want the answer from 2, 3 or 5 or 10. Where are others? 209 have for a change joined so fast, so early. Very good, guys. Keep it up. Of course. So immutable objects, when I say immutable objects, you should immediately, anytime you are answering any question, you should always, supplement with examples. So what are the immutable objects? The first one that pops to your mind is string. Anything else? You can also create a immutable objects by making the state final and initializing it in the constructor and all that. Any other example? No, vector is not immutable. Come on, vector state can be changed. Local date, yes. Local date APIs, local time, etc. are all immutable objects. Okay, so immutable objects are inherently thread safe. So famous question. Are all immutable objects inherently? Yes, wrapper classes, you are right. So here, are immutable objects inherently thread safe? Of course, yes. But are the thread safe objects always immutable? No. Vector is such an example. You can change the state of a vector hash table. Its state can be modified. It has initial capacity, etc. So size and all. So that is not true. So this is your immutable objects. And like you said, I can add the wrappers also. Yes. Now finally, which are the techniques which you have learned on Saturday to apply the synchronization? There are two techniques, you know. So what are the two techniques to apply the synchronization? Synchronized methods and synchronized blocks, very right. So you know, synchronized methods also you have, or you can use, it's not both, you know that you don't require both, blocks. So if you are working on a third-party code, or let it be a built-in Java API, hash map, for example, and one thread is putting the entries, and other thread is maybe removing the entries, or the third thread is accessing, like getting the entries. Is hash map inherently thread safe or thread unsafe? S or UN? Hash map I'm talking about, thread unsafe. So are you going to create a subclass of a hash map and write all the synchronized methods, or are you going to write the yes, no is the correct answer? So what will you do in this case? Synchronized blocks. So Java's philosophy is, instead of writing long synchronized methods and losing the concurrency, compromising the concurrency, identify the critical section which is prone to race condition and wrap it in a synchronized block. Okay, so that is when you have synchronized blocks. Now answer the following questions. All these are typical, interesting questions, popular questions. When you talk about lock we identify as a monitor. So monitor in Java, is it associated with a Java object or a method or a block, or is it at the class level? Answer this. The lock is associated at the object level. So here at this point, generally I get a question. Anyone wants to ask me a question at this point? When I say lock is associated with a Java object, I get a question at this point. Anyone? No question is popping out in your mind, popping up in your mind. Okay, so I will ask you. What I had shown you were all the examples of synchronized non-static method, and non-static methods are associated with the object. So it could be a joint account instance. You remember update balance, get balance, etc. Or I had shown that example, synchronization utils, etc. Or that array list, you have seen those methods, etc. But is there a okay? Let me say this. Can you also synchronize static methods? Do you have a concept of synchronized static methods? If you have gone through that synchro utils, you will see I've shown you that example. But are static methods associated with any instance, any object? No. Are you understanding that? So static methods are available. I mean, they belong to the class level. So when I tell you reflection, I've written, by the way, all this in my readmes. I don't know whether you have read it or not. So whenever you'll see later, this is a part of reflection API I'm talking about. Whenever you are loading, let's say employee class, okay, any example in the method area, employee class gets loaded. When I discuss the reflection API with you, you will see there is a immutable class. There's an object of the class whose name is java.lang.class. You have seen that method, objects method get class and all that. So you have heard about it. So JVM is going to create that immutable class object, and which will get created in the heap. So to cut the story short, when you have a static synchronized method, the lock is applied on that immutable class instance. And that immutable class instance, suppose if I talk about employee.class, it is actually represented by emp.class. So when I discuss reflection, you'll understand more. So right now, what is the point to remember? Can static methods be synchronized? Yes or no? Yes. The lock is applied where? On the loaded class instance. And suppose I talk about employee, what will be the name of the loaded class instance? emp.class. So if you want to apply the lock, what will be the target of that synchronized block? Will it be synchronized even as an employee instance, or will it be synchronized in the bracket emp.class? Answer is synchronized in the bracket emp.class. And when one thread, listen to this. I have written all of this in detail in my synchronization readme, guys. So when one thread is calling one static synchronized method on a particular class, let's say utils, can any other thread, listen to the question, can any other thread call non-static synchronized method on the same class? One is calling static synchronized. Can other thread call non-static? Non-static is instance on the same class? Yes, because the thread which is calling static synchronized method will have to acquire the lock on which object? Utils.class at the class level. I mean .class object. Whereas my non-static synchronized method will have to acquire the lock on the utils object. So that is where things get more and more interesting over time. Okay. So let us continue this. So whether it is a static synchronized method or whether it is a non-static synchronized method, the lock is always associated on the object. Okay, now most important question. When does a thread, ordinarily thread doesn't have to acquire the lock to call the method, but in special cases, thread needs to acquire the lock. So what are those special cases? You know the answers, same old question, same old answer. When thread is calling which API? When does a thread have to enter the monitor? Only synchronized method? There are two answers. It is calling either synchronized method or code within a synchronized block. Very right. So when does it? Either by calling synchronized method or code within synchronized block. Okay, next one. Can one single thread acquire multiple locks? That is locks on multiple objects? 100% yes. Again, the write-up is there in the README. But can one lock be shared across multiple threads? These are the, if you don't think about it, you may end up giving wrong answers. One lock is exclusively for one thread, right? So 100% no. If you start sharing the locks, there is a concept of a shared lock, but we are not talking about it here. So now we have made a list of blocking and a non-blocking triggers. So tell me, when will a thread be blocked? So okay, let me say this. The blocking trigger which I'm asking you is blocked on a monitor is the new blocking trigger we are talking about. Again, all of it is shared. Means when, that is when a thread tries to acquire the lock and lock is already taken by some other thread. Are you understanding this? When I say I don't have to see all this time, if I say blocked on monitor, can everyone realize that picture we had drawn together? A monitor is busy, the gate is blocked, lock is already applied. So can other thread also acquire the lock at the same time? Of course not. So here, when you say blocked on monitor, where the thread will be blocked? Inside the monitor or outside the monitor? Obviously, dumb question. Still I'm asking. The thread will be inside the monitor. Come on. Good, I asked you a dumb question. Hello, wake up. The thread could not enter the monitor. When it is going to be blocked? Of course, outside the gate of the monitor. It is failed to acquire the lock. So guys, be clear when the question is being asked. And when will such a thread is not dead, such a thread is not permanently deadlocked or something. So what is the unblocking trigger? When will such a thread which is blocked on the monitor will be unblocked? Simple question. When the lock is released, or when you say when the monitor is free. You can say either of it, both mean the same. Lock released, or I can say monitor free. And when this will happen? When the earlier threads synchronized method or that synchronized block is over, the lock will be automatically released. And the thread or threads which are waiting for the lock to be released, the threads which are blocked on monitor will be automatically unblocked. So they will go from blocked to ready pool, and whenever they get a chance, they will resume the running. Tell me, blocking and unblocking trigger, fully clear to everyone? Okay, great. Now tell me the conditions under which CPU may be freed. You may lose, the current thread may lose the ownership of CPU, but the lock is not released. Think of them as the important popular questions. Yes, a sleeping thread sleeps inside the monitor. Any other thing? Yes, sleep everyone knows. Anything else? Sleep, join, yield. And one more thing, Pushkaraj, you're very good at this list. One more, context switching. No. Wait is wrong. Wait is the exactly opposite. So here, join. A thread which is blocked on join will not release the lock, will release this. Yield also. A thread who has yielded the control will still hold on to the lock. Notify. It was totally wrong answer. Sleep, join, yield, notify, and context switching. Genuine context switching. But what I mean by context switching, your thread, time slice got over. The scheduler pushed it out to the ready state, or the preemption occurred. Okay. So under all these conditions, what may be released? Processor may be released, but will the lock be released? Lock will not be released. Okay. Next one. Can you write a class which has some synchronized thread safe as well as some thread unsafe method? Yes, that synchroutils was the example of it. Can you run the thread unsafe APIs, hash map APIs, arraylist APIs, string builder APIs in a thread safe manner? Yes, we already covered that. How? Using what? Synchronized method or synchronized block? Answer is sorry. So sorry. Just give me a second. So sorry for this. Hello. I'm so sorry. So can you run the thread unsafe APIs in a thread safe manner? Answer is yes. And like you answered already, it is nothing but your synchronized blocks. And you are going to see in advanced Java, which we will start shortly, you will require wherever you apply thread safety, generally we don't use synchronized method approach. They're used at that typically synchronized block. So this is what I wanted to revise. Are you having any questions? Assignment based question I'm not taking here. That I will take it in the lab. But if there is any theoretical question, conceptual question, which is not clear, please ask me now. Anyway, you keep thinking, in between you have it, save it, and whenever I give you such a time again, you can ask me that time. So now we are entering another
sorry to disturb. I have a question.
topic. You're almost towards the end of it. 2-3 topics are remaining. Inter-thread communication. So first, I think I had given you, just a second. I'll just confirm if I've already shared that. D21 help, ready-made code. No, I had not shared. I'll share it now, right away. I'm giving you some code. Please download and extract. It has no ITC zip. And keep your STS open. I hope you open the STS and keep it ready right in the morning. And create a today's project. This is the last project kind of a thing in core Java. So day 22.1. And here under, I hope you have got this. So copy this package, folder, no ITC, under the SRC and tell me whenever you are ready. But then, like I said, you keep the question, data inconsistent there. I can't just look at it. You must have made so many mistakes or whatever, I don't know. So such questions I will handle in the lab. Share your code with me. And without looking at your code, I cannot really predict whether what you have done, what you have exactly tried. So I will be there in the lab today. So share your code and we will discuss it there. You say shared function, don't use the word shared function. It's a wrong this. What you mean, I guess, is a synchronized method. Is that what you meant, Madan? So don't say it as a shared function. You can either say it as a shared resource or you can say it is a synchronized method. We'll look into it in the lab. Just remind me. Okay, guys, have you downloaded and saved it? Yes, tell me yes or no something. Can I continue discussion of the code? Okay, so now start opening the files in the sequence I'm mentioning. Simplest first, employee. Open employee.java. There's nothing there. Employee has a name, ID, name, department ID, salary, constructors, getters, and toString. But if you check toString, am I returning the complete state? No, only ID and salary. Is employee clear? Next one. Look at, utils 2. I'm giving you a minute. Go through the code. I'll start discussing with you. I'll start asking you questions. Okay, I'll start asking you. Let me ask you a basic question. Utils2 is going to represent a shared resource between two threads, which are producer thread and a consumer thread. So tell me, is this shared resource inherently thread safe or thread unsafe? I said inherently already. Thread safe or thread unsafe? Pushkaraj is saying unsafe. What about others, guys? 100% thread safe. What can, I mean, after spending a day on thread safety, how can you say that? Can you not see both the methods synchronized? So if all the API of any class, if either the object is class is immutable, whose state is not modifiable, but here the state of employee is modifiable, so it is not an immutable object. Guys, I just now took a revision. All immutable objects are thread safe, but all thread safe objects may not be immutable. So tell me, is this thread safe object or is it an immutable object? Quickly. Or both or neither? Thread safe, immutable, both or neither. Utils2. It is, again you are losing it. Guys, it's a simple question and I'm getting wrong answers. Immutable means its state cannot be modified. So tell me, is the state of utils2 going to be same always or is it modifiable? It is modifiable. So it is mutable but inherently thread safe, like your vector, like your hash table. Exactly, exact example. Write it. I thought this was obvious, but doesn't look to be, doesn't matter. So it is a mutable but inherently thread safe, since I thought this wasn't required, but let's write it. Mutable. Mutable means its state. You can see this. I'm changing the employee. The producer is going to produce the next employee record. So the state of utils2 is continuously modified. So of course it is mutable, but inherently thread safe, since all APIs are synchronized. Are we clear? Because the start itself was bad. Mutable and thread safe. Clear to everyone? Because people are going to ask you such questions a lot. Okay, so now tell me, who do you think will call this method? Producer or consumer? P or C? It's a simple question. Who is going to call this write data method? Only one answer. Couple of answers at least. Of course, producer. Okay, so now, and obviously, who is going to call this read data method? Producer or consumer? That basic is clear. Now the next question. If suppose producer got a chance, guys, I have prepared you in a proper sequence. So I hope you'll not give me the wrong answer. Suppose producer thread gets a chance. What will be the output here? It's in the initial power on condition. Monitor is free. Okay, before that, monitor is equal to lock. What is it associated with? Is it associated with utils instance, employee instance, or these two methods? Lock is applied to what? We said so many times, Srinivas. Lock is applied to the object, employee object. No, the lock is applied to the utils object, the class which contains the synchronized methods. Okay, so now understand me correctly. While suppose the first line of the output is W entered, let's say producer. What and you can see I have explicitly put the sleep, everything you know. So can anyone tell me what is going to be the next line? The options are same questions I had asked you, test me again. Is the next line going to be write data always, or sometimes you might see R entered by the consumer? Shall I repeat the question again? I said, if suppose you receive the line W entered, the next line, is it going to be write data or sometimes can it be R entered? 100% write data. Means what? While producer is producing the data, can consumer read the records? Yes or no? Answer is no. And vice versa, if consumer enters it, there is monitor free, lock is not there. So R entered. What is going to be the next line? Read data, or can it be W entered? Read data. Clear? So while consumer is reading the data sample, can producer produce and override the existing data sample? Answer is never. So have we, now I've written the questions already. Answer that. It's a Boolean question, yes or no. Read the question. Does the utils class, utils2 class, contains the thread safe API? Yes. So is atomicity, do you expect to see the mutually exclusive behavior one at a time, either producer or consumer? We have not yet seen it. We'll read it in a, we will do it in a minute. Okay. So here I've written in explicit manner, while producer is producing data, can consumer read it? No. And vice versa? Answer is again no. So we have already achieved the synchronization. So today's big topic is, have we killed all the problems in a multi-threaded scenario, or are there going to be any more problems, additional problems observed even after you apply synchronization? And answer is, of course, you are going to see the problem. So as always, you will observe the problem and then we'll fix it. Are all the statements clear so far? I'll summarize it. Utils2 represents the shared resource, contains read and write method. But if a producer thread gets a chance and starts writing the data sample, I have put enough sleep and all that for enough context switching. Can consumer interfere? Answer is no. And vice versa, while consumer is reading the data, producer cannot disturb it. Are we all good here? Are we all clear so far? Okay. So now open the producer task. Next one, open the producer task. Go through it. So, guess who is going to create the utils class instance? Your choices are main thread, producer, or consumer. Who is going to create this utils class instance? Of course, the moment I say shared resource, how many copies of shared resource we will have in the application? One singleton instance. So that will be created in the main thread, and main thread is going to call this constructor to pass. Are we good again? So you can see I'm just passing the reference, and the actual object creation is going to happen in the main thread. So now you know the thread template. We've been working on it for last 2 days. So you'll see started thread, of course, a producer. I've given the names as producer, consumer. And here I'm generating some hard-coded data. I mean, generating the data. So while not exit, famous, exit flag is like by default, you don't have to initialize, it is false. And here, what will be the first? Okay, forget that. Who is calling whose method? Your task or thread is calling the shared resources thread safe method. So tell me, if the lock is already taken, if the monitor is not free, what will happen? What will be the state of the producer if the lock is already taken? Will it continue to run or will it be blocked? Blocked on the monitor. Very good answer. Complete answer. I don't have to ask anything further. The moment you give me a complete answer, of course. And what will be if the moment the lock is released, which will be the first data sample? I told you I'm hard coding it. 1, AA1 name, HR department, and 100. Okay. Incrementing the counter. And now I hope you have realized the effect of sleep. Sleep causes a lot of randomness, leads to rigorous testing. So I'm not going to allow you that remove the sleep and make the code work. No way. I don't allow you to touch the sleeps. In the presence of sleeps also, you should be fixing the problem if there is any. That is how people ask you. Okay. So you're not going to touch the delays. Let them be as it is. In case of any exception, of course, the whole thing is aborted, thread over. Now, here, is this thread going to run indefinitely or till exit condition? Simple question, simple answer. It's not while true. So it is going to come up on the exit condition. And here, is this the my own stop method, or am I using the thread classes stop method? Our own API or the built-in API? Our own API. It's not a Java thread. Thread's stop method is prone to deadlocks. So here, guess smartly. Who do you think will call this stop method? Which thread will call this stop method? Choices are producer, consumer, or main. Main. Producer doesn't call. Where I have called the producer classes in front of you. Main. So like other day, we are going to ask user to press enter to stop this observation. And then I'm enabling the exit flag. So now I have made a copy sorry, of producer task into consumer. So can you tell me which will be the only line number which I must have changed? Give me the line number before opening the consumer. Line number 16, absolutely correct. So producer is calling the synchronized thread safe produce data method, write data method. Consumer is calling the read data. Open the consumer task. It is a copy paste. You yourself can see that. Spend a minute. Okay, so rest of the things are the same. Is producer working on its copy and consumer working on its copy, or are they sharing the same copy of utils? Sharing or individual copy, same shared copy, shared resource. And as you guessed already, all I'm doing is read data. You might be wondering that why I'm not displaying the data, because I'm already displaying the data here. So why two outputs? That's why. Same code copied into this thing, consumer. Now finally, open the tester, test producer consumer. Let's start looking at it quickly. What is happening here? How many instances of shared resource? Single shared resource instance created in line number 9. Creating names of the threads. Creating producer task. So has the thread been created or thread doesn't exist? I've given all the answers here. Thread does not exist. Where we have created the thread, thread is in a does not exist state. The what is it called? Constructor is well known. So what are the two arguments to this constructor? Runnable task instance and the name of the thread. Thread enters the new state. And when I say t1.start, thread enters the ready pool. Are we all good so far? Are we all clear so far? There's nothing which is complex. You have been doing it. If you have been practicing, this should be very easy. Okay, I'm specifically adding a tiny sleep. So tell me, in this case, 100% guarantee which thread is going to start first, producer or consumer, or unpredictable? 100% producer, because 10 milliseconds sleep is more than sufficient for the underlying operating system and the JVM to start a thread. Okay, so I'm making sure that producer produces the data and that is read by the consumer. Same things you will see for consumer, creating a consumer task, attaching thread to the task, or you can say attaching task to the thread, whatever, and starting. So at this time, at this point in time, how many runnable threads exist in our JVM? Don't count garbage collector. 3, main, producer, and a consumer. And as usual, the other day I already gave you the practice. Here I'm telling user, keep on observing. So you can collect a lot of data, sample data, observation data. And here, when you call this in a main thread, which thread is blocked on input? Main thread is blocked on input. So the complete competition is between, producer and consumers will keep running. So after you press enter, which thread will be unblocked? After I press enter, which thread will be unblocked? Main will be unblocked. So it will go ahead and then it is calling the stop method of the tasks. You remember the stop method? in stop method, I'm toggling exit. If exit is true, what will be the value of while not exit? Not exit will be what? False. And the loop iteration will be over. No exception. So it will skip the catch block and thread will be over. Likewise, consumer will be over because I'm calling stop on both. But it might take some time, in you sending the stop command and actually thread stopping. So I'm waiting. I as a main thread waiting for the children threads to finish execution. And finally, main over. So tell me, is the entire code clear, starting from employee to the tester? No ambiguities, no confusion in the code? More answers, guys. If there's a confusion, tell me that this is the class I didn't understand. Tell me the line number, I can re-explain. I'm still waiting for people. Either ask question or say yes. You cannot stay silent. I'm giving you both the options. I'm not saying that you have to say yes either way, but respond. Responding is compulsory. Okay, so here, now run this and let it run for a while. 10-15 seconds is sufficient, guys. And anytime, I'm just pressing the enter. So check. Okay, you also, you can check your own console. So here, first thing is started the thread producer. W entered means producer called the write data method. Press enter to exit. This was the output from the main thread. Now, after 10 milliseconds, the consumer has started. You can see that. Now important things begin. So who is producing this? Who is writing this data? Producer. Which sample? First data sample 1 and 100. So producer started and producer W exited. Okay. You can pick up any sample. Check. Is there any between W entered and W exited? Is consumer disturbing it? I'm not saying you trust whatever I'm saying. You pick up any random sample, do the random sampling. Yes or no? Answer is no. And while between R entered and R exited, is producer thread producing the data? Check it out. Don't blindly say those things by the tone of the question or whatever. 100% not. So in short, is our code still suffering from race condition? Is there a race condition in the code? No. So have we written perfectly synchronized code? Answer is yes. Agreed with me? Everyone agrees with me? So first level of problem we have solved. Now look little more carefully in the data samples. Okay, so I'll highlight. So producer produced the first data sample, consumer consumed it. Right or wrong, correct or wrong, good or bad, something. So highlighted code. You also will find something in your console. Is it all good so far or not? Quickly. Correct. It is all fine. But now if you see this, which is the thread which has got back-to-back another chance? Consumer. Can you really control the scheduler? Can you really do this thread producer after that consumer that? Can you control the scheduler? Answer is no. So just by adjusting the sleeps, I mean, just whenever you'll say you are playing with the sleeps, I'm saying I'm playing with the practical delays. And I'm telling you, this is what delays are there in practical life. You give me a solution. That is what is the discussion. So tell me here, if I'll highlight the whole thing and tell me problem exists or no problem exists in the highlighted code. Problem or no problem? Problem exists is the one of you are saying, couple of you are saying. So tell me, what is a problem? Here you are reading the same sample multiple times. So what is this condition called in the jargon? Stale data. No control. You are completely off track, Girish. You never had a control to start with. So you're not fighting for a control. You're fighting for the consistent results. So here, what is the problem here? Stale data condition. You have read the data sample, you means consumer thread, and you are rereading the same data. So stale data causes what? Redundancy. So is it a correctly running code or is there still a bug here? You can see there is a bug here. You can pick up any samples, check, pick up. So W entered, producer entered this, whatever, 14th data sample, and the same data sample was read couple of times. So which is the problem we have? We have a problem of stale data, redundancy, same data getting written multiple times. Getting read multiple times. Is everyone understanding the problem or not? Or are you thinking this is all cool? This is all correct. This is not correct. Okay. So now let us reverse the sleeves. Okay. So open the code, utils 2, and in utils 2, swap the sleeves, make one 300, make one 10 or something. Just opposite the sleeves. If you are not able to manage it fast, you can work. I mean, you can refer to what I'm doing. Just in producer. So producer, make it fast. See, sometimes in real life, you can't say which operation is going to really. There's no way you can say that write and read are exactly going to happen at the same time. You can't control any of it. So I've just done the opposite sleeve and run the code again. And you watch after a couple of seconds or a minute or something, and you tell me problem or no problem. Okay, the answer is problem. What problem, you tell me? Which problem, please? Yeah, I told you, Akshata, there is a problem. So which problem? Is this a stale data issue? Wrong, Diksha. That is not how you say this. Is this a stale data? No. Stale data it is. Is there, guys, stale data means you are reading the same data again. Little bit of jargon has to be known by now. Are you reading the same data sample again and again? That's your stale data. No. Here, it's obvious. I thought I'll get the answer. Here, writer has read the first sample, reader has read it. Fine, all cool. But here, now see, writer wrote the second sample, third sample, and then reader read directly the third sample. So what will you call this condition? Is it a stale data or what is it? Data loss, data overwriting. Guys, you have lost couple of samples in between. The moment slightly producer and consumer go out of sync, not out of synchronization, out of sequence, you get a problem. The moment producer gets back-to-back consecutive chance, which is the problem you are observing? Data loss or stale data? Data loss. And the moment slightly consumer runs faster than a producer, what is it you observe? What did you observe? Repetitive data read, that is a stale data condition. All these guys, all these terms are typical terms we use in database. We should never have the data redundancy or stale data stored. Imagine that the consumer was reading the samples and storing it in the employee rate table, which we will start in the second half. And you will see if you have the data stale issue, you will be storing the same data samples, causing a redundancy. So either way, we have a problem. So now answer my next question. Are there problems observed even after applying synchronization? Answer is, I hope everyone has got it. I've spent so much time to get you to this problem condition. 100% the problem exists. And what is it? Is it a synchronization issue or is it a sequencing issue? It's a sequencing issue. So what is the ideal sequence you want? What is the sequence you want? Producer and consumer should go hand in hand. Meaning when the producer produces a data sample, can you control the scheduler ever? Get that idea out of your head. You can never control the scheduler. So if the scheduler gives back-to-back another chance to the producer, should producer go ahead and overwrite the earlier data sample? No. Yes, somebody is saying, guys, how can it go ahead and produce this, overwrite the sample? It should check, has this data been read by the consumer? If the answer is yes, then it should produce the next data sample. Otherwise, what it should do, it should get blocked. It should wait for the consumer to finish the data read. On the opposite side, consumer got a chance. Should it blindly read the data, or should it check is it a fresh data or stale data? It should check. If it is a stale data, should it continue and read the stale data, or should it wait? It should wait. It should wait for the producer to produce the next data sample. So in short, this write and read, this sequence should continue. Everyone agrees with me? Understood that? So that is what is. So now it is okay. So till now, producer and consumer were synchronized. Means while producer was producing the data, consumer could not disturb it and vice versa. But now I want to have the communication between the two threads, which is nothing but called as process level. It is called as IPC, inter-process communication. And when we come down to the thread level, it is called as ITC, inter-thread communication. Are you getting it? So producer is going to check and produce the data sample, and it is going to tell the consumer how and all is a detail, very easy detail. So it is going to tell the consumer, now the data is ready, you go ahead and read it. And vice versa, whenever consumer has read the data sample, it is going to tell the producer, I have done my bit, I have done my job, I have read the data, now you produce the next data sample. So what we want to add towards the end is sequencing logic, which is nothing but the handshaking communication between the threads. Understood the statements? Understood my point? Okay, so we will never add anything directly to the code. So draw the flowchart with me, because with that, making the changes in the code will be very easy. So I will of course share, but it is good if you draw it with me and you will understand it like inside out. So the title is nothing but inter-thread communication. I don't know again. Have you heard a term in your OS concepts called as semaphore? Yes. So what we are bringing in is nothing but a concept of a semaphore. But what is the good news? What is the best news I can give you? Does a Java developer have to dirty its feet by coming directly at the OS level? Do you have to know the OS calls and all that? Answer is no. Do you have to do any native programming? Answer is no. You just stay in your Java level and let JVM work it out for you. Okay. So here, what we are going to do is, first tell me which is the shared resource. This whole discussion is utils or something, utils or utils 2. I forgot. I'll just check the name of the class what I've given. Utils 2. Yeah. So utils 2. And which are the APIs? The APIs are read and write. And both of them are synchronized. They are synchronized methods. You know that. So if you know about the concept of a semaphore, I hope you know the concept of a binary semaphore. Binary semaphore can have what values? 0 or 1. So here, what is the equivalent to binary semaphore in our Java world? I don't want to leave my Java and go to operating system and native programming. What is equivalent to that? Quickly, I get the answer here. No answers, Boolean, very right. So what we are going to introduce is add a Boolean flag. When I say Boolean flag, what I mean is a Boolean variable, and just make it as a this thing. It's going to use the non-static method, so we will keep it as a non-static member. Private Boolean data ready. Okay, so the moment I say this is the beginning, this is the what do you say, initial thing. Okay, so we're going to introduce a flag here, data ready. Now start answering. The moment I say here data ready, what are the two possible values data ready can have? You tell me this way. Oh yeah, you tell me. It's an easy question. True or false, right? So for on condition, if I have not initialized it, what is the default initialized value of a data ready? True or false? it is false. So let us start exploring the false branch first. You can start anywhere, but initially it is going to be false. So I'm just starting with false. Okay, suppose data ready condition is false, which is going to happen in the power on condition. So tell me, can you control the scheduler, as in, can you predict which thread will get a next chance? Answer is no. So here you fork and create two conditions. There is a equal probability that either producer thread may get a chance or a consumer may get a chance. There is an equal probability, equal likelihood that producer may get a chance when the data ready is false, or a consumer get a chance. All good so far? All clear so far? The discussion? Okay. So now think, okay, you tell me, producer is a task, I mean thread. It is going to call the run method. So always, relate the concepts with the code for best clarity. So producer gets a chance means what? It starts executing the run method. So which is the main thing, which is the main method we are calling from the run is write data. So the control comes to utils 2 and tell me, if the data ready condition is false, should it continue and produce the data or should it wait? So put it all together. It's a simple logic. I'm not expecting any mistakes. See, I already got a mistake. Guys, data ready is false. Data is not ready and producer got a chance. Guys, you have a building logic issue. Or, that is what is the heart of any technology, not just Java. Other day, I asked you something like a joint account and the values of the deposit amounts, and only you give me wrong answers. So please work on your logic building. Okay, let us try again. Data ready is false. That means, is there any earlier data sample which is unread? Answer me. Is it not answered? Heard? Okay, no. So if the data ready condition is false and the producer getting a chance, is it a favorable situation or an unfavorable situation? Favorable situation. Then why you're saying it should wait? It should go ahead and write the data sample, isn't it? It is data ready is false. That is your toggle. That is your what? Communication flag. Exactly like your binary semaphore. So mention it here. So here it should, in that write data method, we are going to add this check in a minute. So here what it should do? Should it wait or should it produce the data? Let me try it once again because you all gave me wrong answer. It should produce the data. So here it should produce the data. That particular part of the code we will execute. But after producing the data, this is your communication between the two threads. So how will it tell the consumer, I have done my job, now you can come in? Yes, please. What is it? It should. You are totally out of this thing. Did I ask you any APIs? Don't show me the Java APIs. Tell me the logic. You are having a problem. You are struggling with logic. Toggle the flag. Exactly. So here, data ready. Now what should I make this? Data ready, should it be made true or should it be made false? Okay, now you are getting it. So data ready should be toggled to true. Okay, you cannot control other threads. Scheduler is going to do that. Okay, so you do your bit and just go ahead. Now explore the next scenario. Here, data ready was false. This is not, I'm not discussing in sequence, guys. I'm giving you the conditions. You're going to discuss 4 different conditions. Okay, so now explore the next condition. Data ready was false and here consumer got a chance. Don't misunderstand me. I'm not saying after that this. I'm giving you the probabilities. Data ready was false and consumer got a chance. Favorable or unfavorable? At least we are clear on that. So tell me, should consumer go ahead and read the data or should it get blocked? It should get blocked, right? So here consumer, how can it, if there is data is not ready, if the data is not prepared by the producer, it should get blocked, right? So here, okay, it should, you can say it is. You can say your wait for data being ready, as in get blocked. Okay, so this is one branch over. Now I hope you won't have any problem in discussing the other branch. Suppose data ready condition is true here. Again, draw two possibilities. There's an equal probability that producer might get a chance. There's an equal probability a consumer may get a chance. That is exactly opposite. So I hope you don't make any mistake. And I hope you'll be understanding what I was trying to say earlier. Okay, so tell me, if data ready condition is true and because of the scheduling policy or scheduler, producer gets a chance, favorable or unfavorable, should it continue to write the next record or should it wait? Of course, it should get blocked, right? So here, again, I'll not say so many things. I'll simply say get blocked. Are you understanding why it is called inter-thread communication? Producer and consumer are communicating using a binary semaphore equivalent, which is a Boolean flag. So here, blocked, willingly get blocked. It has to get blocked willingly, voluntarily on its own. And here, if the data ready is true and consumer getting a chance, favorable or unfavorable? Of course, it is a favorable condition. So here you can say, go ahead and read the data. But after reading the data, what it has to do is, it has to tell its partner. So what should I do? After reading the data, toggle the flag. So what is the value I should say? Data is being read. Data is being already read. So toggle the data ready to false. And this can continue throughout till user presses enter. So tell me, are all the branches clear? The four all branches are clear, because we're just going to add this in our code. In the next copy, we'll make a copy, so you'll have full things. So I have just one question to ask you. Which is the method you have seen so far which will 100% cause the blocking of the invoker thread? Have you seen the wait method already? I don't remember discussing it, Prashant. Sleep. Okay. So I want to show you, if you use sleep method for blocking, what will it cause? So I don't want to give the answers before testing it out. Okay, so let's try this blocking condition with sleep. And if there are any problems, we'll first observe the problems and then fix them. Okay, so go ahead to your Eclipse ID, say Ctrl+Shift+W. And let's create another copy, not a project copy, package copy. So say no ITC, Ctrl+C to inter-thread communication with sleep. Just make a copy from no ITC to ITC with sleep. That is a blocking API we are using here is sleep, and then we'll observe and conclude correct or wrong. Done the copy? Okay, now open that. And you don't have to look into all these classes. Where is the shared resource? I have already separated this into layers. So all you have to open is utils2, which is the flag. Start doing it fast now because I have already explained the whole discussion is done. Private Boolean data ready. Just add a flag. And here the first line don't touch, W entered. And here you check, will sample. It's like polling. While, like how you have a event, single event poll loop in JavaScript, similar thing. So while data ready, while data ready means till the time data is ready, should it go ahead or, should it continue to, should it get blocked? In simple words, what I'm trying to ask you is, should I write it as while data ready or while not data ready? logic building requires lot of efforts. You're still not getting it. Read it like English. While the data is ready, do you want the producer to continue or get blocked? Get blocked. So that is perfect. So till it is a sampling duration is 300 millisecond. Every 300 millisecond you are checking. If the data ready is still true, be in this loop. So it is while data ready. If the moment the control comes next, what does it mean? Data ready has become true or false? False. So if the data ready is false and producer has got a chance, can it go ahead and write the data? 100% yes. What is the only thing you have to do is now tell your partner, tell the consumer, I have done my job, now you do yours. How do you do this? Data ready equal to true. Understood the changes? All is I've already shown you the flowchart. Just put it in the code. Logic building, guys, practice a lot. Exactly opposite in consumer. Okay, so has everyone done this? I can share the copy in case anyone is struggling. I hope no one is struggling here. Okay, next one. So let this be as it is, right? And then should you directly consume a consumer, or should you check? We should check. So now what should be the check here? While data ready get blocked or while not data ready get blocked? I hope now you're realizing the mistake in your thinking. So while not data ready means what? Till the time data is not ready, how can consumer go ahead and read the same data sample multiple times? You can pick up this sleep from here and put it here. So this is your sampling rate. Every 10 milliseconds you are checking, 10, 100, whatever, some delays. I'm just putting some polling delay. So if till the data is not ready, continue to get blocked. When will the control come to the next line? When the data ready is true or data ready is false? Data ready is true. And once the data ready is true, this is a perfect time for you to read the data. So continue to read the data. And before returning, I'll have to notify my partner. I'll have to tell my partner that, okay, I have done my job. Now you produce the next one. How do I do this? Toggle the data ready. So what should be the value of data ready this time? True or false? Data ready is equal to false. Very right. Very good. So check. Are both the things added? This is nothing but your communication, handshaking between the threads, ITC. And as you can see, without going to the OS level, all I introduced is a flag and took care of it or taking care of it. Have you done it, guys? Done? Okay. So now you can say again, Control Shift W, save. I hope you have saved. And don't run the earlier one, otherwise you'll get confused. So from ITC with sleep, now here you run press producer and consumer and tell me what happened. What is it you are observing? You tell me your observation. I have already done my observation. What is it you are facing? Quickly, one word answer. Deadlock. It is one word answer, deadlock. What you are seeing is a classic deadlock. Keep pressing enter 10,000 times if you want. 10,000 is overkill. Nothing will go ahead. So that is why, I wanted to show you all these things. That is why we started in this manner. Is everyone not dead, Kanad? No threads are dead. If the threads were all dead, this application would have been closed. So what you are looking at is a classic deadlock condition. Everyone facing the deadlock? Tell me quickly. Okay. And unless until you say abort, it's not going to disappear. It's not going to go ahead. So again, which day? Yeah, hashing algorithm day, I told you to make the observations and write it down. So here also, if you don't, of course, I'm going to make it for you. ITC related observations. It's very important. So let me create a ITC, because these are the really important stuff people ask you about related observations. Okay, so here I'll give the first case as the what was it? The handshaking or ITC with sleep. This is the title and this is what happened. So now let us analyze it line by line. Okay, start analyzing it with me. I'm making that file. If you want, you can keep your own observations. So this looks good. Producer started, fine. Producer producing the data, all good. Okay. After 10 milliseconds, consumer was also started. So let me highlight and ask you, is it all correct so far? Till the time I saw R exceeded. All good, all correct, very good. So can you tell me guys, what is the state of data ready flag here? Okay, why don't I put it here? That's why I write it here. So let me say this here. Can you tell me what is the, you can also make such things. That is excellent for revision. What is the state of data ready? Let me see what you are answering. False, very right. Okay, now, which is the thread which has got the next chance? Which is the thread which has got the next chance? You can see it from here. I don't know, you are almost similar output, a producer. So you remember what is the condition we have written there? While data ready. But data ready is false. So is it blocked or has it produced the second data sample? Produce the second data sample. So now ping it here and check what is the data ready condition here. Now everyone with me so far, data ready is true. Fully clear so far, because you know I'm going to build, and if you say repeat, I don't know from where to repeat. Okay, and I can't repeat so much. It's not like a rewind button. Are you all 100% clear? All of you 100% clear so far? Because now is the problematic case. So now, which is the next? Okay, let me ask you. Can you control the scheduler, as in, can you decide the which the next turn will be given to which thread? You cannot. Okay, so which thread has got the next turn? Back to back? Producer. So now tell me, what is the code? Producer thread calls that write data method. So open the code. It's not a memory game. It's never a memory game. It's an understanding game all the time. So here, open the producer. Data ready is true. Oh, sorry. Okay, producer is going to call the write data. So control click on write data and tell me, if the data ready is true, what is the state of the producer thread? If the data ready condition is true, as you know it is true, what is the state? Absolutely. I just want something more. No. First one who answered blocked on sleep is fine, but one thing is missing. Inside the monitor or outside the monitor? So why don't you give me full answer so that I don't have to grill you more? So here, the state of the producer is, because data ready is, mention it, you're not going to understand it otherwise. So it is blocked on sleep naturally. Where does a sleeping thread? Sleeping thread releases the CPU but doesn't release the lock. That is why I did the full revision before I got you here. Inside the monitor. Understood it totally? Because after that nothing is happening. Got it? So far. Can you visualize? Keep mentioning, keep writing it parallelly to build a story. So now tell me, which of the following is free? CPU, monitor, both or neither? CPU is free. So identify how many threads we started with? 3. Main, producer, and what is it called? Consumer. What is the state of the main currently? Anyone wants to tell me? What is the state of the main? Is it runnable or is it blocked? Again, no memory based. Wrong answer. Completely wrong answer. Yes, somebody told me a correct answer. What is the state of the main thread, guys? Tell me again. Blocked on input is the correct answer. How can you say runnable? That means you're not paying enough attention, not taking enough efforts. it has got blocked here, main thread. You have to visualize the concurrency. So main thread's run method is main. So your main thread, mention it. I thought it was obvious, but no, it doesn't seem to be. So here you can say this. So main is blocked on input. Correct? Producer is blocked on sleep. Okay. So which is the only thread which is runnable in the system? Consumer. Everyone understands me? So now open the consumer task. And what is it consumer calling? The method is read data. Control click. And tell me whether consumer will be able to enter the monitor, as in call this method, or will it be blocked? So in short, tell me at this point, of course, the next chance, the only way, the only thread is, I'll write it here, only runnable thread was consumer. Agreed? So consumer gets a chance and it is trying to call the synchronized method. See, inter-thread communications basis is synchronization. Synchronized method, what is that? Read data. So anyone wants to tell me what will be the state of a consumer? Blocked on sleep is a wrong answer. Blocked on monitor is a correct answer. Guys, consumer is not sleeping. It is waiting desperately for that lock to be released. So answer it, write it properly. Blocked on monitor. Inside the monitor or outside the gate of the monitor? Outside. Okay. So see this. Producer blocked on sleep. Inside. Main blocked on input. And after, okay, so let me ask you a small question I forgot to ask. I had pressed enter. You remember I had pressed enter. So can you tell me, after pressing enter, after user presses enter, tell me, will main be runnable? No. The next condition we have said is T1.join, T2.join. So then it will be blocked on join. In short, that is still blocked. Okay. So now consumer is blocked outside. Now, what is the only thing which can take it ahead? What is the only trigger which can happen to the next cycle? Sleep over. What else? Here, we were sleeping, we're not dead. So producer woke up. Producer woke up. See this. After 300 millisecond. But is the data ready going to be toggled to the false, or is it still going to be true? It's still going to be true. So guys, what you are looking at is a perfect example of a circular dependency. Producer is waiting inside the monitor for the consumer to toggle the data ready flag. Consumer wants to read the data, but consumer is unable to enter the monitor because the lock is already taken. And that is why the deadlock. Understood or lost? So why deadlock? I have to show you the deadlock condition at least, so that you'll be careful in writing the code. So what is it? The condition is why deadlock? It's a circular dependency. Whenever you're in the labs and all, if you have understood it right, fine. Otherwise, just go through all my write-up and conclude. Circular dependency. That is, what is producer doing? Producer is waiting inside the monitor for consumer to read the data. Is this part of the statement clear, where the producer is blocked? And how about the consumer? Is it blocked or is it runnable? Consumer is blocked on monitor, that is unable acquire the lock. Every word which I'm saying, I'm writing it down so that you will have enough processing time. So whatever time you wait, Is it going to release? Is it going to come out of a deadlock, or will it continue to be deadlocked? Quickly. This I'm going to share. So even if you don't write it, it is fine. So 100% this is what is a problem. So can you tell me the root cause of this deadlock? Anyone wants to highlight point that this is the root cause of the deadlock? Yes, please. Can you point out that this is the root cause why it is? Circular dependency is no. Flag you require, otherwise without the flag. Yes, somebody got it right. Sleep is the root cause of the deadlock. Why? Because, okay, let me say this. The moment you say sleep, the sleeping thread, does it release the ownership of the monitor? Answer is no. Sleeping thread continues to sleep inside the monitor. So what is the API we want? Open the flowchart again. So which is the API you want for blocking? The API which will release CPU, monitor, both or neither. Check your answers, guys. It's a wrong answer. Both is a correct answer. You want a blocking API which is going to release the CPU as well as the monitor. And there's only one method in Java, that is wait. Okay, so whether you say sleep or join or yield or that other notify, it doesn't release the monitor. So which is the only blocking API which will release, release both CPU and the monitor is the only method wait. And that is what we are learning. Okay, so the root cause of this problem was the blocking API was chosen, of course, purposefully wrongly. Because if you directly jump, some of the Java guys were telling me wait, but how will they realize when I ask the question, when I give a code which is deadlocked, they cannot solve it. So go there gradually. So now if you open my threads API, which I have shared long back, D20 itself, in the readmes, I'll just take it. I have already shared it with you. Open threads API. And you will see that towards the end, I guess. Yeah. So now let's start looking at the last two methods, important methods, like one at a time. So here, first popular question. All this while, I was giving you, or we were discussing the methods of the thread class. But these methods, wait and notify methods, these are the heart of your inter-thread communication along with that data ready flag. Is the they are the part of object class. These are the methods of object class. So again, it is a favorite question. Why these wait and notify methods are added in the object class? Answer is clear and simple. When you lock an object, when you perform a lock, when you have a synchronized method, the lock is associated with a Java object. That is why the methods are declared in object class. What is the use case? ITC. So now read it slowly. It's a final method, you cannot override it. And these exceptions we'll talk about in a minute. First, understand the meaning. So take a look at this method and tell me, is it a blocking API or a non-blocking API? Wait is a blocking or non-blocking? Waiting for the answer, give me more answers. Again, guys, at the last ending part, you are saying, just now I asked you, is it going to blocking API means what? After a thread calls wait, can it continue the execution or is it going to get blocked? Come on, guys, that is not expected after spending so much time on threads. It's a blocking API. The moment the thread calls wait, your scheduler is going to release the monitor and the whatever CPU, and it is going to wait outside. So this is definitely a blocking API. Sleep versus wait. Both of them are blocking APIs. But what will sleep release? Monitor or a CPU? CPU. Anything which releases the CPU is a blocking API. Without CPU, can your code execute? Guys, simple statements I'm making. So why you're giving me such a wrong answer? So wait is again a blocking API, but in addition to releasing the processor, it releases the lock also and waits outside the gate of the monitor. So please don't show so much of like not understanding, because we have spent so much time. Blocking and non-blocking is the easiest. Okay, so forces the invoker thread to release the processor. That itself means it's a blocking API, and the monitor and waits outside. Understood the meaning? So what is the change we are going to do is here, which is the blocking API we are going to replace it by? I mean, sleep will be replaced by what? Wait. And that is what? We'll see what happens. Is that sufficient or is it not sufficient is what we are going to see. But not before discussing the exceptions. Now, let me ask you, do you remember any other methods which already had interrupted exception? Again, Sagar, you are wrong. I said which methods included in the throws clause having interrupted exception. I got one answer, multiple, sleep and join is the correct answer. The moment you see any method, at that time itself told you. So if your thread is waiting, okay, outside the gate, it is blocked. So can it be unblocked from a interrupt signal from some other thread? It's a yes or no question. Yes. But do we use this interrupt signal as an unblocking trigger for wait? Generally not, because that causes an interrupted exception and the try catch block gets aborted. But is it possible? 100% yes. Now, when will a thread which is called wait may get illegal monitor state exception? Answer is already there. These are the main questions people ask you, or they are expecting you to know. So if okay, let me say this. You have the answer in front of you. What will happen if you call the wait method neither from synchronized block or synchronized method? What you may get? It's a possibility, but it's a strong possibility. What will your thread get if you are not calling the wait method from synchronized method or synchronized block? Which exception? That is what is answer in front of you, illegal monitor state exception. And if you think about it, it should make sense. So understand my next statement, guys. What is, if a thread calls a wait method, what is it going to release? I'm waiting for your answer. I've said this 10 times already. What is it going to release? CPU and the monitor. But guys, if you are not calling, if your thread is not inside the synchronized method or a block, can it own the monitor at all? Can it acquire the lock? Has it acquired the lock at all? Of course not. And simple philosophy, what you don't own, what you don't control, you cannot release. Are you getting the point? So if by a mistake, if you call a wait method without the synchronization, the JVM will laugh at you and will say, what are you doing types? And it will throw you illegal monitor state exception. So that is why we cover the synchronization and we add ITC on the top of it. Okay, so let us try adding wait and we'll observe and conclude. Do it fast. So the only change we are going to do is we are going to replace sleep by wait. So Control-Shift-W, create a next copy, ITC with sleep, call it as ITC with wait. Okay, so you got this. Make a copy. Quickly. Tell me when you make a copy. Control-Shift-W, close everything. You don't have to open anything else, just open my utils. And here, this line has to go off. And since it is a wait is a object classes API, this is not a thread class API, simply say wait. This dot wait. When you say wait, this dot wait, and this is nothing but your shared instance. Okay, so here, what will happen to the producer thread. So P for producer, new trigger you are learning. Will you call it as blocked on sleep, blocked on join, blocked on input, blocked on monitor? No. What is it? It is blocked on wait. Are you understanding? So when you say blocked on wait, what it means? Guys, it had the lock. It had entered, this means it had acquired the lock. So it was not waiting for the monitor to become free. It went inside the monitor, but found out that the data ready flag is true. So should producer continue or should it wait? Of course it should wait. And where it is waiting? Inside the monitor or outside the monitor? That is the main difference between sleep and await. So of course, outside it has released both. So it is definitely blocking the API. The thread is blocked. So blocked API outside the gate of the monitor, or you can say simply outside the monitor. Okay. And similar thing, you do it in this. So while not data ready, a consumer simply has to wait. And why I did not say thread.wait and all? It's not a thread API at all. It is inherited from object class. So this dot wait. So we are, the current object is shared resource. So we have done it. Modified, replace sleep by wait. Everyone means whoever is coding along. Okay. And now say Control Shift W. I don't want you to mix up and run from ITC with wait, test producer consumer, and tell me what did you observe. Do your own observation. Is it working or still a deadlock? Still a deadlock. Try pressing enter. It's not going to come out. It is still a deadlock. But some things have changed. That's why we spend so much time. So if you want, you can pick up this, or I'm anyway taking efforts for you, ITC related observations. So step 2 is we have achieved ITC and we realized that there was a problem with sleep because sleep was not releasing the monitor at all. So this is your ITC with wait and observations. So now observe with me, observe and conclude with me. So far, so good, I guess. Yeah. So just go through the highlighted code and tell me. Everyone understands it? Writer produced the first data sample, reader read it. Clear so far? Respond. Okay, now here, so tell me, again start sampling. So what is the, at this point, what is the data ready condition, guys? True or false? False. This is all logic building. There's nothing about the threads here, more of a logic here. Okay, now, so producer got a chance, cool. And what is the status of the data ready? False. So it is producing the data. Okay, so favorable condition. Favorable. And here, now tell me, what is the value of the data ready after producer has produced the data? Anyone? Easy question. It's true, right? Okay, so this is true. Now, as I kept saying million times, you cannot predict which thread will get a chance first because all these transitions are controlled by your native operating system. So here, back to back, who has got the chance? Producer. So now I'm not going to say anything. You are going to tell me what will be the state of the producer here when the data ready is true. Anyone wants to tell me the state? Blocked on wait, outside the monitor. Perfect answer. Great answer. See, when I say great answer, I got all the points covered. She got all the points covered. So what is it? Yes. So blocked on wait. At the moment I say wait, it is releasing the processor also. So of course, from running it went to blocked and outside the monitor. Okay, cool, done. So now Main is already blocked on input. After pressing the enter, it is waiting blocked on join. So which is the only runnable thread in the system? Consumer. So now compare, guys. See this. After this, W entered. Consumer, you did not see any consumer because with sleep, you were locking the monitor. But now tell me, is consumer entering? Is consumer able to acquire the lock, enter the monitor? Yes. I hope now you'll realize why I put so many SOPs. So now consumer enters it. So consumer acquires the lock. So now consumer is inside the monitor. And what is the condition? Data ready, true. So tell me, is it a favorable condition for this one? Consumer or unfavorable condition? Favorable condition. So has it proceeded to reading the data sample? Yes. All great. And are exited. Okay here. So now it has released the lock. Are you getting this? So here what is the state of the consumer? C for, okay, I'll say consumer is runnable. Okay, at this point it was runnable. Okay, but now you see something. So here R only entered again. And can you tell me what is the state of consumer now? See, I hope you understood this. This was all good so far. Okay, so here now consumer got a chance. So here with data ready is false. So what is the state of consumer here? Yes, blocked on wait outside the monitor. So now just sit back and check. What is your producer? Producer is also blocked on wait outside the monitor, and consumer is also blocked on wait outside the monitor. So here earlier was also deadlock, but because of the circular dependency problem, here also it is kind of the same, but one was blocking the monitor, continuously sleeping inside. So my poor consumer could not enter. So tell me, is it any longer the monitor issue? Is it happening because monitor is not free? No, monitor is all free. It is waiting. So what is the problem? The problem is again circular dependency. But before I say circular dependency, important statement. So important question, let me ask you. The thread which is blocked on wait, will it be unblocked automatically or does it require explicit wake up call? The thread which is blocked on wait, will it wake up automatically or does it require actual, like wake up kind of thing, explicit wake up call? Answer is it requires. Guys, see, if the thread is sleeping, sleep over, unblocked. If the thread is blocked on monitor, monitor free, unblocked. But the thread which is blocked on the blocked on wait requires explicit notification. And that notification was missing or is missing. That is why you are experiencing a deadlock. Okay, so that is these are the various examples. So if you write a multi-threaded application and you get a deadlock, you should know the pointers that where should I debug or what I must have done wrongly. So spending so much time. Okay, so blocked on monitor. So the reason. So reason behind deadlock. Deadlock means what? All the threads are stalled. Whatever time you wait, they are not able to go to the next state. That's your deadlock. So reason behind the deadlock is producer is waiting for the consumer. You cannot give a self wake up call. It's not like an alarm. So producer is waiting for the consumer to what? To send the notification signal, to send the explicit wake up call, which is nothing but the method which is coming up is notify. You can see the wait and notified. The whole thing is around wait notification, and your consumer is also doing the same. And since we have not done all this, of course, it is a classic deadlock again. consumer is waiting for the producer. The signal, it is all about signaling. Producer has to signal the consumer, I have done my job, now you wake up and do your bit. Consumer is waiting for the producer to send the explicit wake up call, which is nothing but the notification. Are you getting this? So this is what is the next API we are having. So read the next method. So which is this method we have? Object class method notify. So there are two methods actually. One is notify and one is notify all. So tell me, if I'm having one producer and one consumer, which method you think we will require? Notify or notify all? Easy question. Notify is sufficient. But if you have heard about multiple producer, multiple consumer problems, most famous problem in this thing, what is it? Multithreading, dining philosopher problem. Have you heard about it in your earlier courses or whatever, dining philosopher, where you have multiple producers, multiple consumers, then you require notify all. Okay, so currently we are just happy with one producer, one consumer. So when you say notify, what it will do? It will unblock. It is a, okay, so let me ask you, notify is a blocking API or unblocking API? Because people get confused here and give me wrong answers and really send me in depression. Wait is a blocking trigger, notify is an unblocking trigger, unblocking API. It is going to wake up your thread which is blocked on wait. So wakes up exactly one thread which is blocked on wait on the same object's monitor. So when producer says notify, whom it is going to wake up? Whom it is going to unblock? Producer is going to unblock whom? When producer says this thing, what do you say? Notify. Who is going to notify? Consumer. And when consumer says in that thread notify, who is going to wake up? A producer. Are you getting this? So which has invoked wait? And again the same problem. Can you call wait or notify without synchronization? Absolutely not. If you make that mistake, you may get 100% times I have not seen getting, but even if you get it once in 100, that is killing enough. So never do that mistake. First apply synchronization and then call your wait or notify methods. But suppose you have got multiple threads which are blocked on wait. Is notify sufficient? Of course not. If you want to unblock all the waiting threads, the broadcast version of notify is notify all, and it will unblock all waiting threads which are blocked on the same object's monitor. So everyone is clear in understanding. I can use notify all, but I don't require notify all when there is a one producer, one consumer problem. So now let us make the last copy and observe and conclude. So here, your code is not going to this thing come out of it unless until you say abort. So abort it. And let's make a copy here. So now you make a last copy as ITC with wait and notify. Control C, Control V. Okay. I'll wait till you do this. Just copy from ITC with wait to ITC with wait and notify. Done the copy? Done with the copy? Okay, so open only the we have arranged. You don't have to look at rest of the code. Open utils 2 directly and tell me change or no change. Of course, the answer is change. What is it we are going to add here? Notify signal, notification signal, a wake up call. So tell me, where should I add this notify? Towards the beginning or just before returning from the monitor? Of course, just before returning. Because guys, if you say somewhere you are in between, you are unnecessarily waking up the thread, but you have not yet released the monitor. So poor consumer will anyway again get blocked on the monitor. Don't do that. So these are all the standard good programming practices. So just do the notification And it's an object class API. So this dot notify means you are calling it on the current shared resource. So tell me here, who is waking up whom? Who is unblocking whom? Line number 17. Who is sending the unblocking signal, or who is sending a wake up call to whom? Producer is unblocking consumer. So here mention it, producer sending. Like how we used to send interrupt signal. Interrupt can also unblock the wait, by the way, but it will throw the exception. And does producer want to kill the consumer, or does it want to simply notify the consumer? Of course, notify. So interrupt is a wrong choice here. Producer is sending the wake up call to consumer. So I'm not wasting your time, but I'll just ask you verbally. If you do only this much, producer waking up consumer, and you run the code, what do you expect? Deadlock or working? Still a deadlock. Why? Because you have done the job halfway. Producer is going to wake up the consumer, but what about poor producer who is going to get blocked? So let's not waste time here. You can try it out. That is why you have a lab session to explore. So here, just before returning, send notification. This dot notify. The wait and notify have to be called on the shared resource, and shared resource itself is utils. So this dot notify, and now everyone knows who is sending the wake up call to whom. In here, consumer is sending a wake up call or wake up signal, whatever you call it, wake up call, wake up signal to producer. Understanding the statements? Are we clear about wait notification? So now open the corresponding tester here and let's try running it. So first observation, deadlock or no deadlock, at least for a while. You'll see there is no deadlock. Keep it running till eternity types. So we don't have that much time naturally. So you can just like put this. And sometimes you'll see, all the time I'm not guaranteeing, sometimes you'll see the application is not executed, terminated. But that's a smaller problem to solve. Ignore it. First, let us see whether we have achieved the inter-thread communication as in sequencing logic. So start looking at your data, collect your some data. Writer wrote the sample, reader read it, all good. Writer wrote the second sample, reader read it. So are you experiencing any, pick up some random samples, don't trust the initial samples. Keep reading it, running it for whatever long time till your heap crashes. So here, pick up anything. Where is that? Wrote 25th sample, read 25th sample. Don't be under the wrong impression that you're controlling the scheduler. Scheduler is on its own. So here you can see back to back producer getting chances. Only thing is we have applied synchronization and ITC so as to never enter into stale data condition as well as data loss. Pick up any sample. That's why I told you, whenever you are getting any question, they will arrange the delays and all, and they will say that this is the code you have. Now fix it. So that is the practice I'm giving you. So coming back to the point, tell me, are you experiencing any data losses? You check, don't trust by what I'm saying. You check it in your code. Is reader getting all the samples? Check it. Read data 33, read data 34. That's why I given the numbers and made it so easy for you. Read data this. And are we having the data redundancy as in stale data, reading the same data again? No. So this is the solution of inter-thread communication on the top of a synchronization. So other than the ending problem, are all the problems solved? Are you understanding that there's no deadlocking? You keep running this for longer times and you can check 0 problems. So let's solve that. Sometimes occurring. See, when I say the problem occurs even 1 in million, it is a problem to solve because you never know when it will strike. So as you can see, after I press the enter, the application, see this application, you can check in the top left corner, application has not yet terminated. You got that. So you can see there are so many outputs I have given. So can anyone tell me, what is the state of consumer? Read from my write-up, I mean my console, and tell me what is the state of a consumer? Universal states does not exist. No. You are wrong, Kunal. States I'm talking about. Sushant is right. Dead. Can you not read this thread over? The consumer is dead. But what must be the state of a producer and a main thread? Don't say active, guys. Okay, let me ask you. Blocked? Okay, dead or alive? First thing. Alive. Otherwise, application would have done this. Runnable or blocked? Alive is a correct answer. Runnable or blocked? Blocked. Otherwise, why? Okay. Can you tell me what is main blocked on? Blocked on join. And what is producer blocked on? Producer is blocked on what? Why it is not coming out? Blocked on wait. Who was supposed to notify it? Who was supposed to send a wake-up call? To producer, consumer, but consumer is dead. So are you understanding? There's nobody to wake up the producer. So producer is blocked. And because producer as a child thread is not over, your main is blocked. Clear or not clear? Okay. So now let's trigger. It's a minutes thing. So you about the code. Now don't make a fourth copy or whatever. It's a small problem to solve. Now here I want to show you. Notify is one of the what is it called, unblocking triggers for wait. Which is the other one? Which is the another unblocking trigger for wait? No idea, no clue. Interrupt. No. Notify all is the similar one. Notify all is the same category. But I have an interrupt signal. So let me show you that also. You will say then why you did not use the interrupt earlier. If you say interrupt, the other thread gets an interrupted exception and becomes dead. But now is the time I want to make the threads dead. So here, open the tester for the last time. And here, after calling this, check the status of the threads. Okay, which status? Alive status. So after sending the stop signal, if the thread is alive, that means, maybe its partner is dead or whatever. So simply if P1, T1. P1 is the task. If T1 is alive, let's interrupt it. So all this I have already given you in the first earlier days. And if T2 dot is alive, let's send the interrupt signal to T2. So if the thread is blocked on wait, can interrupt signal unblock it? It's a Boolean question, yes or no. Answer is yes. By the way, you can send a notify, but notify means this dot notify. So you'll have to say on that shared resource notify. So better operation towards the end of the application is sending interrupt. So here, what this will happen is T1 will be unblocked on interrupted exception. Okay. And similarly here, if T2 is blocked on wait, it will be unblocked on the interrupted exception. And then you check whether your application terminates. Run it 10 times. Guys, don't be just happy if it works once. Run it multiple times to get that feel, to get that confidence. And then we will talk about something else. So let this run for a while. We are approaching a break, so I'm going to tell you to keep running it. Somebody is low on the memory. I remember somebody was saying that he exhausted. Then I can't help you. But otherwise, it should get running. It should keep running. So, and now you say press enter. You can see first observation, application terminates. When does a JVM terminate? Not when only main thread is over, all non-daemon threads. User versus daemon thread is the next topic anyway. So all non-daemon threads are over, and you can see they have got the interrupted exception and all of that. And since producer and consumer is over, main was waiting for them to be over, application is over. So this is a full and final form of your multi-thread application, which has basic concurrency, which has synchronization, and you cannot call wait notify without synchronization. On the top of that, you have inter-thread communication without leading to any deadlocks or live locks or any blocking. So, understood something out of it? The whole discussion, got a feel? So what I'll do is, you can produce, you can pick up the data samples. You can pick up so as to complete those observations, I'll just pick up some of the data samples. And when I share this ITC related observations, so now the third thing which we did is ITC with wait and notify. The observation was no deadlocks whatsoever. And here I'll say continues running without any deadlocks. So it is extremely important. See guys, you might understand it today and remember it for next 1 or 2 days, but exam time or interview times and all, you're not going to. So I'm just trying to help you. The write-up, the threads API, the observations, the interpretation of observations, and the code. If you keep 3 things together, I think you'll be able to revise, or I think you'll be able to answer any questions. And on the top of it, if you want to read any time in detail, you have Java docs. So compulsory reading exercise of today. Not in the labs. Labs you don't read, don't waste too much time in reading, but maybe in the evening and all. So here, it's an object class API. So please open object class, and they have given a beautiful description. Very, very good, excellent description for wait. Of course, there are wait with timeouts and all that. Causes the current thread until it is awakened. So a lot of things they have mentioned in the wait, as well as notify and notify all. So 100% worth discussion, worth going through. Yeah, I'll do that, Shubham, in a minute. We are anyway pausing for a break. So what is your reading exercise, everyone? You are definitely going to spend at least 10-15 minutes any time. Generally, I'll say not in the lab because lab is all hands-on. So definitely read 3 methods: wait, notify, and notify all. From which class? Thread class or object class? Object class. And to get a better idea. So we have talked about all the things, but it is always good to read it in a formal manner. Yeah, so before taking a break, let me share this zip. If you want, you can go through it. So 22.1, I'll share that. Observations also, you did not note the observations, Kunal. You should keep doing this. I'm sharing, that is not an issue. I'm never saying no to sharing, but you all should also take efforts, not just rely on me on taking all the efforts. Otherwise, things don't work that way then you don't get the whole feel. I've sent you both ITC related observations and 22.1.zip. And before taking a break, next topic is going to be user threads versus daemon threads. So I'll send you that also. So take all of that. Actually, what I'll do is, I'll just, one sec. I'll give you the day 22 helpful. So instead of, sharing in parts, of course, I may add something more, but that is later. So I'm creating a day 22 help zip so that it has cloning, no ITC. I'm sorry, what was that? Something, daemons and users and all that. So all these things you can have later. We are going to discuss it after taking a break. Don't worry. So the 22.1 zip was a code. Take this help, which has ITC related observations also. And we are going to resume in 1 hour. Are there any urgent questions before that? Are there any immediate questions, or would you like to go through and then ask questions? Tell me. Go through? Fine. You need time. And we are today I'm there in the lab. So we have the whole lab session to ourselves to this also. So let's have a 1 hour break and resume in an hour. So be here by 11:05. See you around.